I'm Daniel Ver, coordinator of the Advanced Engineering and Computing Hub and specialist in quantum computing. This roundtable addresses a central question. What are the priority levers to enable French and European industry to become a world leader in a quantum value chain? Together, we will explore the roles of key industrial and institutional players in advancing computing technologies. And to answer my questions, I'm pleased to welcome to Andrea Levol, leader coordination Crédit Agricole, Jean-Philippe Bourgoin, Deputy of Executive Director for Technology Research and Director of the Electronics and Infrastructure National Program Agency, CN, Guillaume Renaud, Head of AI and Emerging Technology Ampere Renault Group, and Joseph Michael, Head of Quantum Computing EDF. So to begin, Andrea, as a banking group, how do you concretely support the quantum ecosystem, especially startups?
Thank you, Daniel, for this question. So we heard before already from Laurent that, well, as a banking group, we have several options, so we have several cards to play. So the most traditional one is certainly the traditional banking service. Donc these are companies, this is a new emerging industry, so we can accompany them with our traditional banking service. But we also have other cards to play, like with our Bank Indo-Suez wealth management, for example. They created an initiative that's called Startup Connections. And with this Startup Connections, well, this is a way to promote startups to our clients for investment or also for business relationships. And well, sometimes, not for all, we cannot do this for all, but sometimes we can also invest and help directly startups. And well, there's another prominent form, and I think that's even the best form of support. It's really to be their client, to work with them on real-life use cases, because that's also the industry needs real-life use cases to get quantum out of the lab and get it really into society. And yeah, there we can help them to generate revenue and to really work on real-life use cases.
Thank you, Andrea. Joseph, what position has EDF taken toward quantum startups, and how does your experience in high-performance computing benefit to the ecosystem?
Yeah, thanks. First of all, thanks for the invitation. I always enjoy to be here. So yeah, EDF has made the decision to have an open science mindset. So very soon in our quantum journey, we shared our use cases. We are publishing what we are doing publicly. We communicate a lot with the startups so that they gain some legitimacy working with a big company like us. On top of that, these guys didn't know nothing about high-performance computer. So these startups are very exciting, but they come from labs, and most of them didn't know what's the HPC world, what it takes to industrialize algorithms. So very soon we offered them the possibility to be in contact with experts from HPC, experts from algorithms. And this expertise is free for them. It's free to the quantum world. And finally, what we decided also is to be at the level of these guys, of these startups, so they don't have to explain us what's a qubit. Now we know what's a qubit, we want to go one step forward. So I think that during the meetings that we have with the startups, we are at the same page. So they don't learn us how to work. It's a collaboration that we are working on so that it can go faster, I think.
Okay, thank you. Jean-Philippe, what are, in your opinion, the technological prerequisites to ensure strategic autonomy in quantum technologies?
Well, thank you, Daniel. First of all, I'd like to point that despite the tremendous progresses that have been made during the last 5 years with 100 QPUs delivered by companies, mainly startups, this industry is still very young. And in my opinion, it's not only a matter of technology, it's also a matter of holistic strategies at the national and European level. And though it's a bit early to point specific technologies, I'd like to stress a few points. First of all, it's important to support all kind of platforms because there is no winner standing out right now. If one wants to have access to technology, the support has to be broad. That's the first issue. The second issue is about focusing on industrialization issues, as well as mastering the hardware-software co-design, because this is a weak point right now. And it's important to identify and develop the key enabling technologies like cryogenics, like command and control, like quantum error correction, and so on and so forth. And about the last two aspects, there is a national program called Q-Loop under the national strategy, and which is run by CA and addresses exactly this. The pilot lines that are developed at the European level, and some of them are operated by CA, are also supporting this. The third aspect is mastering the cooperation between HPC and quantum computing. And at the same time, developing the software stack, the algorithms, and the interoperability. It's very important. And there are programs at the national level, the HQI that Loïc Leloir mentioned, and as well as at the European level, the Euro HPC. Finally, we should absolutely not forget developing use cases, because it's when you confront two applications that you know if it works or not. And let me stress a final point there, answering your question. The role of the national and the European strategy is to think in advance and anticipate for the time where QPUs falter and QPUs will be available, and make sure that at that time, whatever the geopolitical situation, the European players will have access to those QPUs. And that's the role of the strategy, and that's the role of a national research organization like CA.
Yeah, okay. Joseph, you would like complete Jean-Philippe's answer?
Yeah, thanks. So, of course, sovereignty is a very tough topic, but from our perspective as big utility companies, we need the best possible electrical network and the best possible electricity production assets. Should it be by relying on foreign countries and foreign companies? So it's not our topic. Sovereignty of quantum computing is not our topic. But of course, we face a risk if we depend on one country that decide from a day to another to stop the delivery of its quantum computer. It can be a problem. So that's why we pushed that hard to make the best possible technology to be European. And I think we can do it.
Guillaume, how do inter-industrial alliances contribute to accelerate disruptive innovation in quantum technology?
Yeah, so thank you for having me. First, I'm really happy to talk about our involvement in the quantum field. So, well, basically, in my opinion, collaboration is really essential for driving and accelerating innovation. And, well, of course, quantum technology is still at the beginning, so we see that there is a lot of work to do to go to real value, real business use cases. But that's definitely why we are involved with Autonomy Group, with being connected with startups and research labs, and also other industrial players in the field. We do that because we believe that first, I think that there is no single company that can actually cover every aspect of innovation in the field. It's going very fast, and we have a lot of competing technologies. So our position is more like an end user of the technology, of course, in the future. And what we do today is that we are exploring on early use cases, sometimes sharing it with other industrial players. And by doing so, we also share methodology, and we also share on the sometimes simple things that as a lesson learned. And this helps us to have a common understanding of the technology, and also avoid duplicate efforts, because it's not easy to get into the technology itself. And I think as quantum technology matures, we have also a role to play in aligning the value versus technology, because you can't just brute force your way into a value. I mean, it's really important to understand the technology, but at the end of the day, you have to try, experiment, and iterate, and upskill your teams to see where the value is actually. And I think that we are really lucky to have a strong French ecosystem, and it really fosters these collaborations. And I think that a lot of energy is going today in hardware and low-level software stack, and I will be really happy to see it going more like in software and application stack, so we can actually iterate and experiment on it.
Joseph?
Yeah, regarding collaboration, yes, definitely I agree with Guillaume. Nobody can do anything alone, and I think no country can do everything alone. So we need to work as a team here at the European level. We saw a lot of very nice collaboration between big companies and startups, thanks to Paris region and their PAC Quantique, which helped a lot. We see very nice collaboration between big companies in Germany. I don't want to name, but just say do it between, I don't know, Bosch and BMW, and very nice to see big companies working together. But I don't see that much of collaboration between big companies across Europe. So big French company, German company, and I don't know, Netherlands company. The only way to do that right now is to work to enter into a European project, but we know that it can be burdensome for some companies. But I think that we could work together beyond the European Commission will, and we could do something together. We have no any issue in working with E.ON in Germany or Alliander in Netherlands. So it's a call. I know that there are a lot of German companies here, so please come and see me.
So, Jean-Philippe, what role can hybrid public-private ecosystems play in supporting strategic economy?
Well, it's plain and simple. It's a central role. The quantum technologies are very complex, and what's at stake has been mentioned already many times this morning. So public-private cooperation is a must there. There are other reasons. One of them is that in quantum technologies, science and research and development technologies, applications do evolve at the same time. It's not a sequential process as usual, so it's also calls for strong cooperation. And on another plan, the level of risk is very high because these technologies are still not mature, and the challenges are huge. We've heard some of them in the technical talks, brilliant, by the way, that we had this morning. And that's the reason why the national and the European strategy have brought a large ensemble of tools to support those ecosystems with R&D programs, with public procurement, with support to startups, with support to education and training, with building capability, with building infrastructures. And those are very welcome, and I do see in all of these programs a very strong cooperation between research, academia, and private companies, be them startups or big groups. So I think it's really how this is happening right now, and it's great. It is like this.
Okay, Andrea. How can we align the different timelines of research, startups, and a large industrial group? Given the complexity of quantum technologies, how can industrial and scientific timelines be aligned?
Well, that's a good question because it's not that easy, because there is a lot of uncertainty. You know, in fact, we do not really know when those computers will be really sufficiently strong, really to have enough to perform really what we want to do with it. So there's a lot of insecurity there. We also mentioned already the software stack. It's not yet there at all. Well, there is some, but it's not yet ready, for us to so that we can really use it more to even to test. So what we do is we try to align these time frames by several factors already, by strategic planning. So we try to look at use cases and try to estimate what we would need for that. And it's not only a question of qubits. It's as we heard before, it's a question of quality of those qubits. It's a question of connectivity, of speed. So and it's so far we have very few benchmarks for really working this properly out, but we are trying to estimate what is needed so that we can then match that insight with the roadmaps that are published by the startups and also by the big players for sure. So that's one part of it. Another part is certainly that we also really try to take advantage of incremental innovation. So as we step forward, we see that already with as said, even if the high performance quantum computers are not yet there, we can already work with quantum inspired, and often even the fact just to have a look at the problem again. So in a bank we have really very complex mathematical problems, and when we look at the way we do it now, the traditional way, and we try to better it, to stimulate it with quantum inspired methods, then we can already have a real advantage. And currently, a little bit while waiting for the high performance computers, we are also really looking for incremental innovation there. And then there is another big when we go ahead with these timelines, we need time also. So even if there would be a computer, the high-performance computers ready tomorrow, we would not be ready. Because what we need is also invest in education and training. Because learning quantum is a really slow process. So it's not just that you have your data analysts and you pay them a 6-month courses and they are experts in algorithm. So it's not that easy, and we see these parallels also when we have other revolutionary technologies that come up. I would like to draw a parallel with AI. So AI really, I mean, we use it since a long time, but it really came out to the big public in the end of 22, and since then the applications, they are really multiplying. We could in a very exponential way, we could even say, and this is a technology that is much easier than quantum, and still it took us some. Well, at Crédit Agricole we installed a data lab that was caring for these technologies already in 2016, and so we were ready when it finally really take the big light and really came out in the spotlight. We were ready. But it took us a couple of years to be really, put everything in place and train and really know what we want. That we want an ethical, ethical AI, etc. And I think we have to do the same steps also for quantum technologies, for quantum computing. Just that it's much more complex, and there are more. Open factors, so to really align those timelines.
Joseph?
Yeah, the question of the timeline is a good one. So for big company like us, just an example, the brand new French nuclear reactor that just started to deliver its first electron late 2024 was first introduced in the 80s within the company. And another example of that is the one of classical algorithms that, as Andreas said, between the publication of a paper on classical algorithm, a major paper on its implementation within an industrial framework, you have at least 5 or 10 years. So it takes time to implement something, it takes time to industrialize something. So we won't, as Andreas said, if you guys, if this startup delivers 1,000 logical qubit tomorrow, we won't be ready to use it because the software stack is missed. And maybe we did the mistake to do this crazy qubit count. So it's not just a matter of qubits; it's a matter of software. The big nightmare for me would be to have this very nice 1,000 logical qubit machine without any application, without any software stack. It would be like having a game console without any game. So it will be a disaster. So we have to work on our side. Of course, startups won't tell us the unexpected application of their technology. It's our part of the journey to imagine the future opportunities of this technology, and you can't do that if you don't involve your business people within your company. So there are a lot of things to be done between now and the 1,000 logical qubit machine, but it's our part of the job together with academics.
Jean-Philippe, in view of what has just been said, does strategic autonomy rely solely on technology or also on the control of use cases and business models?
Well, I think it's not, and it's clear that it's not a simple technology problem. Of course, if you have no decent technology, that's the end of the road. But that said, what we heard is that the problem is much broader. It's a matter of developing a complete value chain at the European level, having in mind the dependencies that we may have, those that we want to avoid. And among these issues, the aspects related to the use cases are very important because, as I already mentioned, it's when you confront to practical applications that you know if you are making progresses and if it's worth the effort. The other aspect is related to the business case. Right now, we see that most of the startup, if not all of the startup, are going. Hardware startup, they are going for a full stack approach. It's very reasonable. They are pushed by their investor that maximizes the value of the startups, and that's perfectly okay. But at the same time, we can project and see that at some point there will be some consolidation. And that's why we think it's so important to think in terms of key enabling technologies, in terms also of interoperability, and consider the other aspects which are absolutely crucial of talent education and training. Without talents in this domain, again, this will be a lot of deception, if I may say so. So I think it's not technology only. It's much broader.
Thank you, Guillaume. To conclude, how can we support strategic autonomy? Are there gaps in the current value chain? And how can we address the collectively?
So, not a simple question. I think that strategic autonomy really comes from aligning our efforts across sectors on the long run. And I think on the long run is the most important part, because we are all enthusiasts here now, but it's going to be a journey. It's definitely not a sprint, the quantum race. It's more like a long marathon. So making sure that we are all invested on the long run is very essential. At Renault Group and Ampere, we are really driven by customer needs and technology agnostic. So basically, we invest in solutions when we see value for customers. And of course, there are steps and also in quantum. Andrea was mentioning quantum inspired, so we are also exploring with tensor networks for getting value, because if we get value before getting a real quantum advantage, we can continue to fund the effort. So that's important. But anyway, we are staying committed to contribute with alignment with tech and value, and with especially with our use cases and the quantum advantage that we are seeking on those use cases. Now, regarding the gaps, I think it was mentioned. We see that algorithms and more robust software stack is very essential. We were discussing with Joseph the other day, and we were surprised to see that only a handful of research labs in France, for example, are specifically working on algorithm research and development. So I think this is one. And I think that as in AI, AI actually it's transforming and continue transforming our businesses today, with thousands of engineers applying daily. I think we can see the same future happen for quantum. But we need really these tools to develop on and upskill, of course, because it's not simple to learn. And I think there is no doubt that if we stay focused and all on the same track, we can actually get strategic autonomy on the field.
In 1 minute, Andrea, Joseph, same question for you.
Yeah, I think it's important really to help this ecosystem put in place, to get it put in place, so to really build partnerships, to work together as we do in working groups, because at the end the real mathematical problems behind for what we want to use quantum, at the end it's from one industry to the other. It's quite similar, so we have quite similar needs. So I think it's really all about now helping the ecosystem to grow, to be strong, and this for all the French and European companies, and also the collaboration between the industry players.
Very same. Collaboration is key. At the European level, we definitely miss a lot of people from the academic world working on algorithms. Most of the algorithms comes from the US. At the end of the day, there won't be any secret formula nor any secret algorithm, just secret implementation. So we need open science here on the algorithm part of the story. So we need to promote academics working on algorithms, and I think it's key for European industries.
A final word from your point of view, Jean-Philippe?
Well, there are a few gaps, like hardware, software, co-design, like software stacks, like algorithm, like industrialization that have to be taken care of. But altogether, France and Europe are in the race, thanks to pioneering position in research, thanks to a national and a European strategy that have been working quite well so far. And we do expect that this will continue with the Quantum Act, and we try and work to help this happen.
Okay, thank you all for your great contribution.
Thank you.
Thanks, Daniel.
Thank you.